everyone, so today we're going to continue with sketching polynomial functions. So we're going to do just a quick recap of last lesson. So first, this is a polynomial function. A polynomial function is a bunch of powers of x that are added and subtracted and that have coefficients. Okay? Those powers of x have to be positive and they have to be whole numbers. The largest power of x, so in this case n, is the degree of the polynomial, and whatever the coefficient is of the x to the n term is called the leading coefficient, and that leading coefficient helps us determine the shape of the graph, mainly the end behaviors. And end behaviors are just what happens as x gets extremely small, so approaching negative infinity, or extremely large, approaching positive infinity. The degree of a polynomial function is the same number as the maximum number of possible roots for that function. So if we're dealing with, for instance, a quartic, which is a degree 4, then there are 4 possible roots maximum. The degree and end behavior of a polynomial function are determined by that lead term. So in other words, the term with the highest exponent when it's fully expanded. If it is an even degree function with a positive leading coefficient, then it rises at both ends. So it would look like that. If it's an even degree function with a negative leading coefficient, it falls at both ends. So it would look like that. And then if it's an odd degree function with a positive leading coefficient, it rises to the right, falls to the left. So it would look like that. And if it is an odd degree function with a negative leading coefficient, it rises to the left, falls to the right. Okay, so remember, for the even ones, think about a parabola. So you just have to imagine what happens with y equals x squared. And for the odd degree, you want to think about the line y equals x. Turning points. So between roots, there will be turning points on a graph. So that really just means the point where they change direction. The maximum number of turning points is always one less than the maximum number of possible roots, which is really another way of saying it's one less than the degree. In the case of equal roots, so that's when there's a multiplicity of 2 on the root, this can produce a turning point on the x-axis, so a bounce. So steps for sketching a polynomial function. First, you want to identify the roots. Okay. To do that, you really need it in factored form. So if it wasn't already factored for you, you would have to factor it, possibly using the factor theorem and synthetic division. Then you want to determine coordinates for the y-intercept, and you want to look at the degree and the leading coefficient before putting it all together in order to sketch your graph. So let's go through a few examples here. So just like before, we're going to get all that information that we need. So we're going to want the degree of the function, the leading coefficient. Those two things will help us determine end behavior. And then we need the x-intercepts and the y-intercepts to graph. Okay, so this is a degree 3 function. And if we expanded it all out, our leading term would have been x cubed, which means it is a positive leading coefficient. And if it's an odd degree with a positive leading coefficient, then just like a line, it goes from Q3 to Q1. Okay, the x-intercepts are x equals -1, 3, and 5, which we just read off of our bracket. And the y-intercept is when we plug 0 in for x, and we would have gotten 1 times -3 times -5. So it would be 15. We are going to need a scale here, just like with every graph that we've done. So I'm going to put in a scale going up by 2s. And then on the axis, I have a y-axis scale going up to 15. So if we plot all of our x-intercepts and y-intercepts, we have an x-intercept of -1, 3 and 5, and a y-intercept of 15. Okay, there's no special degrees on any of those brackets, so it means that we're going to just go straight through all the x-intercepts when we hit them. And starting down in the third quadrant, following that end behavior, we're going to start down there, we're going to hit our first x-intercept, hit the y-intercept, turn around, hit our next y-intercept, turn around, and then hit the last one, and we end up with the proper end behavior. Okay, so there's a rough sketch. Once again, depending on how high or low you go, yours will look a little bit different, but it should still hit the same key points and have roughly the same shape. Here's our next one. So this one is a little bit more challenging because it's given to us in expanded form. So in expanded form, we can actually find out some of the information, right? Remember, we need degree, we need leading coefficient, we need end behaviors, we need the x-intercept, and we need the y-intercepts. So the degree, when it's fully expanded, we can just look at the leading term, so the term that has the highest degree, in this case it's 3, that would make it a degree 3 function. The leading coefficient of that degree 3 function is negative. So if it's degree 3 and negative, that means our end behaviors would go from Q2 to Q4. Okay, we can't find out the x-intercepts, we're going to need to factor this for that. But we could figure out our y-intercept by plugging in 0 here. Okay, and in fact, if we plug 0 in, we would get a y-intercept of 0. But we still do need to factor it because we need to figure out our x-intercepts. So let's begin by factoring this. So there is a common factor here of negative x. So I'm going to start by pulling that out. And that would leave me with x squared minus 8x plus 16. And now that's a quadratic, two numbers that multiply to 16 and add to negative 8. It's actually going to be a perfect square trinomial. It would be negative 4 and negative 4. So instead of writing x minus 4 times x minus 4, I'm going to write it as x minus 4 all squared. And now we can read off our x-intercepts. So from this lone x, it counts as its own bracket, and it causes an x-intercept of 0. And then from the second bracket here, it causes an x-intercept of 4. And we know that on that 4, because it's squared, we are going to have a bounce. Okay, so we need to remember to bounce off that 4. Just like before, we're going to do a scale here. Okay, and we're going to draw in everything that we know. So we're going to draw in our x-intercepts of 0 and 4. And we would draw in our y-intercept, but that's also the origin, so we already have it. And now all we have to do is follow our end behaviors and bounce on the 4. So we're going to start up in the second quadrant. We're going to go straight through that 0, turn around at some point. And remember, we want to bounce on that 4, so we're going to need that U shape. So I'm going to do the bounce. And there we have our graph. And checking, we did get those end behaviors that we needed, which is perfect. So we have one more example. You guys can give this one a try yourselves, and then unpause the video to see the answer. And there we would have our final graph. Okay, so you guys can get started on the homework, and if you have any questions, please email your teacher.